Hello, ESNEXT 2020. Thanks for joining me today. And big thanks to the organizers, Fred and Drew, for having me. I'm going to share with you all some ideas about internationalization and data visualization. I'm Naomi Meyer, and I work at Adobe as a software development engineer on the globalization team, where I do internationalization engineering for Creative Cloud products. Here's where you can find me online, and I would love to continue the conversation online. If there's anything that you found meaningful or have a strong opinion on, please let me know. I'd love to hear it. So this year, with our global pandemic, with COVID-19, we've all witnessed how data visualizations can be a powerful international communication tool. Here's an example of the flatten the curve visualization, which I'm sure you've all seen before. I like this example because we've seen really the power of data visualizations to effectively communicate critical information and to tell a story. And I think that the stories that we tell with data can be really powerful, and it's important to ensure that that information is not misperceived or mistranslated by diverse audiences across the world. So this critical data, the stories we're telling with the data, often used in the context of news, it's important to keep internationalization in mind. So this is kind of an example of what I'm talking about. I'm sure we've all seen visualizations like this a lot lately. This one's published on The Guardian, a news agency. So if we go into the browser and we translate this visualization into Chinese, we can see a few internationalizations, and those are what we're going to cover today. So first we have numbers. Numbers and integers are very important, and they need to be formatted correctly for each distinct locale. Also colors. Colors can have different cultural significance, and that can really vary across regions. So that's important to take into account in your design thinking. Also, of course, dates and times need to be formatted correctly across regions. And finally, if we take this data visualization and we translate it in the browser into Arabic, we can see some right to left language challenges that should be addressed. Clearly there's other internationalization issues like the translation of text, but those aren't what we're going to get into today. Instead, today our agenda is to start with some definitions, then we'll move to numbers, dates and times, and some JavaScript examples. Then we'll move to right to left and iconography and some emojis, and finally we'll end on color. And overall, the aim of internationalizing our data visualizations is to create experiences that are equally usable, relevant, and meaningful for users from across the globe, to really amplify the voices of our global users. So I'm not going to get into the guts of things like D3 or Vega today, because those are awesome data viz frameworks. But instead what I want to do is focus on ideas that can easily carry across frameworks and tools. Because overall my goal is to encourage you all, my fellow coders, to try and avoid your assumptions and to think more globally about how to build data in the form of visualizations for the full World Wide Web. So this is a paradigm that we often talk about on my team, where we have the most granular level of translation, or T9N, where hello becomes hola, konnichiwa, bonjour. Then localization, or L10N, where in the United States, in kind of American English, we spell localization with a Z. But if we go across the pond in the UK and London, we might spell localization with an S. They're both English. One is English as spoken in the US, one is English as spoken in the UK. They're just different regional variations or dialects. Or locales. So that's what we go into in the process of localization. Then internationalization, which is the process of preparing the full app on the engineering side to be shipped with translations. And these all kind of fall under the umbrella of globalization, or G11N. And the more I look at this paradigm, I think that there's kind of another higher order component here, and that's accessibility and innovation, because culture is deeply rooted in our thinking patterns. It affects how our users interact with and benefit from digital experiences. So internationalization really goes beyond translation. And by acknowledging cultural characteristics and celebrating differences, we're creating with accessibility and also with innovation. There are so many products that we all use and love today. Things like touchscreens, text messaging, voice assistants that were originally built for disabled users for accessibility, but we all use them and love them today. So it's great for everyone to broaden our minds and innovate with globalization. So another story we can see here by looking at these two visualizations, they kind of tell a different story. The bar chart on the right shows that the majority of people on Earth do not speak English as their first language, whereas the pie chart on the right shows that the majority of digital content on the internet is in English. So I see this as an opportunity for us to improve and expand digital content across languages. So let's talk about some of the ways we can do that. Let's start with numbers around the world. I found this image online and I love it because it's a representation of how numbers can really vary across the world. And I see it and I think, wow, numbers are beautiful. So how can we handle that in our apps? Here's a JavaScript example where instead of hard coding an integer or a number directly on the page, what we can instead use is the JavaScript Intl API, which comes natively out of the box with JavaScript. And here's the intl.number format, which lets you create a reusable formatter instance that supports locale-aware number formatting. And since it enables creating a reusable formatter instance, it's more efficient than other methods. So here we're passing the locale and the number, and this is a long number of 123 trillion plus. So if we look at this logged across a variety of locales, we can see some difference. In English, the comma is included every third integer for this long number. In German, we see a period, Russian, a space, and then interestingly, in Tamil and Hindi, the comma is included in a different location within the integer. And that's because they have different number systems. I love it. Another example is here from Gapminder, and it's a great visualization tool, and they have I18N functionality where you can translate, and here's the Russian version. But if we look on the axis, we can see a little localization bug here, where 16,000, 32,000, and 64,000 have been shortened with a K for 1,000, which is not the correct locale-aware symbol in Russian. So how can we fix that? The same intl object has a parameter called notation compact. So this is amazing. I'm really excited about it to get locale-specific symbols. So if we see that same number here shortened into compact notation, which is often used in data visualizations to make the numbers more human-friendly or human-readable, there's a wide variety of these locale-specific symbols. There's a Russian symbol, and then, of course, in Tamil and Hindi, the comma is in a different place, and we can see in Arabic and Farsi here, the numbers are reading right to left, which we're going to get into later. Similar to notation compact, there's also experimental additions to the intl object. There's a link for more information. Here's notation as scientific with the optional parameters of style as unit and unit as meter per second, and notation as engineering, where I'm sure these are tools that would be very useful for, our COVID data visualizations these days. And this is from the TC39 proposal from Matthias Baynard and Shane Carr. So big shout out to them for the awesome work they're doing, really kind of beefing up the JavaScript intl object. And here's a quick example of a well-localized, internationalized Japanese data visualization. So let's move on to dates and times around the world. Time zones. So I love this viz because it shows how bright and jarring time zones are. They're notoriously confusing in computing. Here we can see the 25 nautical time zones that are separated by lines of longitude. And most time zones on land have a standard time offset from Coordinated Universal Time, or UTC, by whole numbers of hours. But several are offset by 30 minutes or 45 minutes from the nearby hourly offset. And if that's not wild enough, time zone is not always equal to offset from UTC, because many time zones have more than one offset because of daylight savings times or summer times rules. So often, we're using time as an axis on our graphs, and if you're displaying today, that is something that you really want to get correct. Also, the age-old question, what day is it today? If we look at this example, it depends on where you're asking, right? Sometimes this is January 2nd, 2021. Sometimes this is February 1st, 2021. And, 2021, the year when everything will be better, right? Hopefully. But we want to make sure that we're formatting our dates correctly across locale so there's not confusion. So another cool INTL tool here is this date time format, where we can pass in the year as numeric, the month as short, and the day as numeric, and format a range of a start date from an end date, which is common, in a graph or a data viz. So here's how that is logged across a variety of locales, and I love it. I think it's awesome how varied it can be. So here's a few tools that I recommend. I use a lot of React, so some of them are React specific, but there's awesome open source projects to help with dates and times. Also, the last shout out for the JavaScript INTL object. There's a lot in here, and you don't have to negatively impact performance by loading all of these additional libraries. You can use what's in the INTL object, and there's experimental additions that are really exciting. I love reading about them on NVM, so check it out there. Let's move on to right to left around the world. So, Arabic is the 5th largest language on Earth. And if we add other right to left languages like Pashto, Urdu, Farsi, Kurdish, Hebrew, and so many more, there are many hundreds of millions of native right to left speakers. So it's a great customer base, and by enabling right to left, you are letting these users have a better experience online and use their native mother tongue and native direction of text. So this is a story that I've heard talked about in the context of right to left. I'm not even 100% sure if it's true or not, but the story goes that there were some Western advertisers who came to Saudi Arabia and wanted to advertise Coca-Cola. And this was the storyboard that they drew up. And in their left to right context, the story goes, someone's lying on the desert, they're drinking Coke, and then they run and they're happy. But they forgot that in Saudi Arabia, folks think and read right to left. And so the story was read, someone's happy and running, they drink Coca-Cola, and then they're lying on the desert. So this was a fail of right to left advertising. The campaign did not do very well. Another example here is this infographic we can see from Lebanon, where all of the text is reading right to left, and then also the images are intended, the story of the infographic is intended to start at the green and move to the red there. So it's really a mental shift of users who will start on the right side of the page instead of starting on the left. So this is true for characters, for text, but numbers are handled differently. There's this concept of bi-directional numbers. Many languages like English, Russian, German, French are monodirectional. They just read left to right. Here's an example from Morio Schuttlinger, who shows that in Hebrew, the text reads right to left, but the numbers read left to right. So there's two directions happening simultaneously in line. And then on that second example, you can see that there's English content, which might be user-generated content that is reading left to right with numbers, left to right, but then the Hebrew numbers are right to left. The Hebrew characters are right to left, but then the Hebrew numbers are left to right. And there's lots of different directions happening simultaneously in line, and bi-directional numbers are mind-boggling. So here's some examples of some visualizations that show this. Here we can see a Hebrew language 5th grade math book, where in orange, the text is right to left, but then the integers are left to right. And then in the bottom, the mathematical notation is left to right, but the text next to it is right to left. Here's another example of a high school calculus book from Jordan, where everything on the page is reading right to left, including the square root sign there and the x and y axis of the graph. And here's an example of in Hebrew where the x and y axis have been changed, and now everything is reading right to left here. And this example is from the Maldives Anti-Corruption Commission. And while the X and Y axes are reading left to right, if you look at this story chronologically, blue is 2018, green is 2017. The story is intended to be read right to left here. So the more I think about bidirectional numbers, my mind is just blown. So it's great to avoid assumptions. And here's some examples of great libraries to help. So let's move on to iconography. All imagery and iconography is closely related to society, culture, beliefs, religion, and political values. And that's why it's so important to be careful and intentional when selecting images for different regions. So these examples are from the Adobe design system called Spectrum, and they show that when images include people, it's essential to pick pictures of folks who are dressed appropriately for the region, and to remember that the definition of what is appropriate attire can vary significantly across regions. And then this other example is a picture that might represent relaxation in the United States, like kicking back your feet. But in Southeast Asia and in countries like Thailand, displaying the soles of your feet is considered very rude and offensive. So when serving an international audience, be respectful and aware of different traditions and manners across different regions, and then act accordingly. This is one that I feel passionately about because I worked as a teacher in Japan. And when I first got there, I used the Western check mark to indicate correct when I was grading my students' homework. But I quickly learned when their parents called me that in Japan, you don't use the check mark, you use the circle to indicate something is correct. So I had to fix everyone's homework. So sometimes correct is a check, sometimes it's a circle, sometimes it's an X, and that's something you really want to get correct. So speaking of these emojis, I find emojis to be absolutely fascinating because they're used by the whole world online, or nearly. Billions of people across every language encoded into Unicode use emojis. And so this is a study from Gretchen McCullen, the author of the book Because Internet, and Ben Metlock, the CTO of SwiftKey Keyboard, that I think is fascinating about emoji differences across languages. I have a whole nother talk all about emojis. You can check it out on my website. And I can totally just talk your ear off about emojis, but here's a few examples. So the heart emojis is used 4 times more by French speakers than any other language because Paris, is the city of love. The flower emojis are used 4 times more by Arabic speakers than any other language. Drug emojis are used most in Portugal Portuguese and Australian English, which are also countries that happen to have some of the most permissive drug laws in the world. And then Santa emojis are used most in Danish, Norwegian, and Swedish. Here's another fascinating emoji study where the authors hypothesized that different emojis would be interpreted differently by respondents across gender and age based on the emoji's emotional perception. And they found this to be true for the unamused face there and the face screaming in fear. Older and younger respondents interpreted that meaning differently. And the face with rolling eyes emoji, they found to have a gender variant of interpretation. So overall, with emojis and images in our data visualizations, a good rule of thumb is to try and avoid gestures, sarcasm, and slang, as they are very difficult to translate and are often mistranslated. Also with emojis, they vary across platforms. They're kind of like fonts. So I think this is a fun example of emoji I'm sure we've all seen a lot lately, and it's variants. And with emojis, it's good to keep in mind the cultural context and know that emojis are dynamic and can change. So obviously, the face with nasty emoji have seen a significant increase in usage. This is a study from Emojipedia, which is a great resource I recommend, but good to keep in mind. So let's move on to color. Color is a major factor in creating effective data visualizations, but color have different meanings and cultural significance around the world. So who remembers the great dress debate of 2015? There was this squall of dismay and confusion on social media over this image of the dress because the whole internet full of people looked at the same image and saw different colors. And this helped make us acutely aware of our brain's processing and the neuroscience of color and vision. So in the book, The Secret Lives of Color, the author Cassia St. Clair talks about this as an example that color should be understood as subjective cultural creations. So let's look at a few examples that are really clear to paint this picture. So first, the color red. In Western context, red is often used as a stop sign, warning, error messages, bad. But in Chinese culture, red is a color that has more positive associations. Here on the left is a Chinese wedding where the folks are wearing red, and on the right is a red envelope, which is used during the Chinese New Year to pass money. So red means wealth, good luck, happiness. In the middle, we also see in the ancient Inca tradition, the deity Mamahuoco was said to have emerged from the cage of origin wearing a red dress. Also the color white. So here's a Hindu funeral and a traditional Chinese funeral where the family members of the person who have died are wearing white. So, some cultures white is for funerals and death, and some cultures white is for weddings and more different emotional feelings. Also the color purple. So there's a story of Julius Caesar. After his son was born with Cleopatra, he wore these purple Tyrian robes. Then laws were passed that said only emperors were allowed to wear Tyrian purple. Anyone else could face death. So in parts of Italy, purple is a color associated with bad luck. And then the Vatican, during Lent, the Pope dresses the Vatican in all purple there. So we have the tools in our CSS or CSS and JS, whichever you prefer, in our toolbox to change color modes. We can have dark mode, light mode. We know how to have different color variables. We also know how to target different languages in our HTML markup. Here we have a lang tag. So we can use the lang class or the lang selector to change the CSS. Here we're loading additional fonts, which is common for different languages. But it is possible, technically, to add different colors or different color themes for distinct color meanings around the world in our data visualization design to be more inclusive and culturally sensitive. So overall, this function is internationalizing our data visualizations for a global audience of users will return improved experiences and amplified voices. So please join me and try to avoid your assumptions, broaden your mind, innovate, and build for the full World Wide Web. Thank you so much. Let's continue the conversation online.